Hello, my name is Izwanul Irzan bin Razain. We are from Group 7. So today we would like to present regarding the characteristic of three-phase induction motor. So this project is designed to give students a deep understanding of the operational traits of three-phase induction motors that widely utilized across industrial sectors for their robustness and efficiency. These motors are crucial in industrial process necessitating a grasp of their torque speed and power speed characteristic to optimize performance under different loads. So the project aims to bridge theory and practice by enabling students to analyze these threats through simulations and modeling, fostering and comprehensive comprehension of motor behavior in practical application. So now let's move on into the procedures of modeling work in Microsoft Excel. Actually, there are several software that we may use to create three-phase induction motor, but for this project, we use Microsoft Excel. So as you can see on our left, that is our workflows on how we create the three-phase induction motor using Excel. So the characteristic of the induction motor that is met is only using mathematical function in Microsoft Excel. Mathematical function or formula is written into the Microsoft Excel to produce results such as torque speed and power speed characteristic. The mathematical function written to get sum of these values is done inside the Microsoft Excel.
Hello, my name is Asrino Rafiz bin Ahmad Shah. My metric number is CE230158 and I'll be explaining the motor model analysis. The performance analysis of a three-phase induction motor involves understanding key characteristics such as torque speed dynamics, efficiency, power factor, current variations, speed regulation, and temperature rise. The torque speed relationship highlights how torque changes at various speeds, including starting and breakdown points. Efficiency measures the ratio of mechanical output to electrical input, with higher efficiency indicating fewer energy losses. Power factor shows how effectively the motor uses electric power and can be improved with capacitors. Next is current varies with load, featuring high starting current and normal running current. And then speed regulation assesses the motor's ability to maintain constant speed despite load changes. And then lastly is temperature rise, caused by energy losses, can damage the motor if excessive, making cooling essential. Analyzing these factors optimizes motor performance, enhances efficiency, and ensures reliable maintenance. Thank you, that's all from me.
Hello, my name is Hazim bin Muhammad Razali, matrix number CE230046. So for this project, there are a process of obtaining motor characteristic, which there are two, which are torque speed characteristic and also power speed characteristic. So the first, in order to obtain these two characteristics, there are procedures that need to be done. So the first thing is select the parameters such as rated voltage, rated horsepower, and also the impedance. So these values determined by using mathematical equation formulas such as speed, voltage, and also current. Secondly, we need to calculate the Thevenin equivalent voltage and impedance using selected parameters. So from the selected parameters previously, we calculate the Thevenin equivalent voltage. After that, we varying the slip value from 1.0 to 0.00 with an interval of 0.01. So using Excel, varying the slip to obtain the torque speed and also power speed. Last, we plot the characteristic from the previous procedure and you can get the graph using the Microsoft Excel function. So that's all from me. I give the presentation to the next member. Thank you.
Assalamualaikum, my name is Muhammad Syafiq bin Muhammad Safa, CE230055. So for the result and discussion for the step A is how do we do in Excel, right? So we need to create an Excel file, and then after that we have to start to determine our value of the parameter that we need to choose to set for the induction motor project. And then by using the value, we have to use the setup program inside the Excel to generate the value that we want, and from the value that we have been generate, we need to come up with the graph for the speed, for the torque and speed characteristic, and also for the power speed characteristic graph. So from the value that we have been calculate using the program inside the Excel, it can be generated by to come out the graph. Okay, so for the parameter that we have been choose is the 400 volts, 4 poles, 20 rated HP, and also for the impedance we have choose the 0.2 ohm, 0.4 ohm, 0.1 ohm, 0.5 ohm, and also 20 ohms. And the mechanical loss is 300, and for the core loss is 200, and for the miscellaneous loss is 0.3. So that is our parameter that we have choose for the setup for this induction motor. Thank you.
Good morning. My name is Muhammad Aishwan Nizam. My metric number is CE230119. So now I will be present to you torque speed characteristic. As you can see in the graph, it's a torque speed, induced speed motor, induced torque versus motor speed. So the induced torque versus motor speed graph illustrates the operation of an induction motor at about 1315 RPM. The graph maximum torque is 439.95 Nm. This torque peak indicates the motor ideal operating position. By keeping the motor running close to this speed, you may maximize its efficiency and turn electrical energy into mechanical effort. For applications that demand torque that is dependable and constant, this ideal zone is essential. For instance, keeping the machine operating close to its max torque guarantees smooth and effective operation in industrial operations where control and precision are crucial. Furthermore, turning around this ideal range can save operating costs and increase energy efficiency considerably in applications like pump and fan system. That's all from me. Thank you.
Assalamualaikum, I'm Muhammad Syafiq bin Muhammad Safa, CE230055. Okay, so this is for the power speed characteristic. Based on this graph, this is an induction motor power speed characteristics curve. From this graph, we can see that the power is increased with the speed until it reached the maximum peak, and it started to drop down. The maximum peak is 62.01 kilowatt. The power increase is crucial due to the strong initial application used, such as pump, generator, fan. But when it reaches the maximum power at some point of RPM, it will drop the power due to mechanical losses, or maybe something about increasing of the friction inside the motor. Okay, thank you.
Hi, Assalamualaikum. My name is Wan Haris Bashir. Today I want to present about the result and discussion for motor performance. For this induction motor, the rated voltage is 400 volt, frequency of 50 Hz, 4 poles and 20 horsepower. The rated speed for this motor is 1500 RPM. Assume the slip is 0.05. The motor speed will drop to 1426. With slip speed of 76, the motor speed will drop to 1424 with slip speed of 76. This happened because the difference between the synchronous speed and the rotor speed. The input power for this motor is 60.7 kilowatt and the output is 51.9 kilowatt. The output power is lower than the input power because of the power losses produced, such as mechanical loss, core loss, miscellaneous loss when the motor is running. The current produced from this motor is 98.48 ampere with 0.47 degree angle from the voltage angle, which is 0 degree. From the difference angle between the current and the voltage, we can calculate the power factor produced from this motor, which is 0.89, which show that the voltage and current supplies are almost in phase and the motor uses almost all of the energy produced. The motor efficiency is peaked at 85% for maximum loading that show peaks performance is achieved at higher value load. That's all from me. Thank you.